There is directed graph. How do we traverse all the nodes without repeating it? Moreover, in the directed graph, there is a loop here, and it is necessary to avoid entering the loop and repeating the traversal. Therefore, we mark the nodes that are being traversed. Today we will introduce two methods, namely BFS, which is breadth first search, and DFS, which is depth first search. For example, this is a tree structure and also a graph. We started from the root node and got there. If we choose to go to the right first, it becomes a width first. If you choose to go down to the child node, it is depth first. This is also just a special case. When we deal with a generic graph, the root node is an arbitrary starting node, and the child nodes are all neighboring unvisited nodes. The first is BFS, which is breadth first search. Combine Python 3 code. This is the code part. You can check it out here. Before traversing, in order to avoid repeated revisit to the same node, an array must be initialized, called visited. All nodes are false initially. There is also an empty queue, called queue. We start at node 2. Therefore, the variable s is 2. Add to the queue and mark the 2 in visited as true. Then, as long as there are nodes in the queue, it loops. First, pop the first element from the queue, that is, s is 2. Output it. Then, all the neighboring nodes 0 and 3 are 2, are joined to the team, and the visited mark is true. Next, start the second cycle. Similarly, the first one in the queue will be injected. It is output node 0. Then all neighboring nodes 2 and 1 of node 0 are queued and marked. However, the visited state will be checked in advance to exclude true, that is, node 2 has been traversed. Therefore, only node 1 will be queued and marked. Where we start the third cycle, the queue, node 3 in the queue. Output. Check the neighboring nodes of node 3, only one self. Visited has been marked skip. The last is the fourth loop. The output and the neighboring nodes are all marked and skipped. Finally, the queue is empty, ending the loop. Then there is DFS, which is depth first search. Combine part of the code of Python 3. Recursive writing is used here, that is, calling itself. The stack of the calling functions can be used to make the code more concise. Then, this function is only used for the processing steps of a node. Then, the visited array is still needed to prevent repeated reversal. This time, we start from node 1, which means that the variable v is 1. First, node 1 in visited is marked as true. Next, output the result. Then, call the total function again for all neighboring nodes of node 1. Then, the only neighboring node of node 1 is node 2. Therefore, the parameter v of the calling function execution is 2, and the flag visited is true. Output. Then calculate the neighboring nodes of node 2, which are node 3 and node 0, respectively. So this loop is executed twice. The order here is not important. For the first time, neighbor is node 0. Before calling its own function, the program will automatically push the current execution position and the variables onto the stack. I only show the required variable v here. Then the called function is executed, which is v is node 0. Visited mark true, output. Then look at the neighboring nodes of node 1, which are node 1 and node 2. However, after starting the loop, I found that the visited were all marked as true, so they were skipped and ended. When the execution of the current function ends, the program will automatically pop the top of the stack and restore it to the original loop. At this time, node 3 is left in the neighboring nodes of node 2 and the call is started. At this time, v is 3, the marked visited corresponding to true, and this is output directly. Okay, in fact, the program will continue to execute, but this will not have any impact, so skip it here. In summary, BFS emphasizes width first, so each child node or neighboring node needs to be saved to the back of the sibling node. It is more appropriate to use a first in, first out queue. DFS needs depth first, so the sibling nodes are saved first, but they need to be retrieved later. It is more appropriate to use a first in, last out stack. Okay, that's all for today's video. See you in the next issue.